Okay, here we are with lab 3. In lab 3, we're going to study this other valve over here called a pressure reducing valve. Very cool valve. What it does is it reduces pressure. But it reduces pressure for certain applications, or more specifically when we want it to reduce the pressure, and that's when it hits a set point. So this valve is a little different. This is a one valve. It's actually a normally open valve. So normally flow just goes right through it. When it reaches a set pressure, it closes. And then anything past the valve will stay at that pressure. So it reduces the pressure by just kind of shutting the line off and saying, no, you can't have any more pressure. Even though the pressure in the system may be at 500, we can set this guy to say 350. The application here that we have for this lab is that we've got a press that's going on, we've got a mold, and it's being clamped together. Now my mold, when I clamp it together, I want it to clamp at 350 psi, because that will create a particular amount of force that's clamping my mold shut. But my system runs at 500. So if I'm running a system on 500 psi, but I only want 350 during the clamping process, then I can use a pressure reducing, because once the pressure gets to 350, and we know that during extension the pressure is not, the pressure is low. During extension it's low, so it will still extend, but when it gets to the end, when it's actually physically feeling the back force of the mold being clamped down, the pressure rises. The pressure goes up and up and up, and then it reaches 350, the set point, and then the flow to that cylinder will stop. Let's put an application, hook this up. Okay, good. So I'm going to put this guy over here, and we'll just start with this. First thing I'm going to do is I'm going to hook up these two lines. Here we go. And this time when we do it, we're going to hook up the drain first. Okay, cool. So I'm going to go over here, I'm going to go over there. Last time in lab 2, we hooked up the drain last. Okay, this time we're hooking it up first. Okay, so here, what I need to do is I need to hook the drain up here. So which is my drain? Okay, so I have to find out which the drain is. That's the drain because the symbol shows me that this is the drain. That's the in, that's the out. Okay, good. So hook this guy up, and again, I have to be careful that I'm not putting this to tank. More specifically, I'm actually putting it on the drain. Now I can go through and I can start hooking these things up. Again, I'm starting with A, I'm going to hook everything up, and then I'm going to move on to B. Okay, good. So from here, I actually have to go to a T, and I know that, but I'll show you in a second how that's working. Okay, good. So I got this line over here, I'm going to go into here, I'm going to go into my A. From here I go to a T. Let's talk about why I go to a T. So what I've got is I've got one line coming in here, it's being split. One goes into a check valve, which we'll talk about in a second, and the other goes into my other pressure reducing valve. So I need a T there, so I'm going to put a T on this hose. And I know that one of my lines goes to a check valve. Let's talk about why it goes to a check valve. What's happening is that during extension, the fluid's going through here, it gets blocked by the check valve and it's forced to go through my pressure reducing valve. But during retraction, I want that flow to go straight to tank. And you know, these pressure reducing valves and also the sequencing valves, they're kind of one-way valves. Flow only goes one way through them. So I can't have the flow going through the valve this way. I have to let it go through a check valve. And I kind of want to bypass my pressure reducing valve completely because I don't want the liquid to try and go through it. So I'm going to hook this guy up and I'm going to the ball side of my check valve. Okay. So I'm going to go over here and I'm going to connect to the ball side of my check valve. And I'm going to go into here. Good. So I've got that. Now my T says that I have to go to two places. The other is I have to go to my pressure reducing valve. So from there, I'm going to go to my pressure reducing valve. And I'm going to go into the in of my pressure reducing valve. So I've got a short distance here. I'm going to use a short line. And I'm going to go into my in. Okay. So I'm going to move forward. Out of there, I'm going to go to my pressure gauge, which requires another T. Okay, that's no problem. I've got a T here, and I'm actually going to stick this on the pressure gauge, not first, because it's very sensitive. I want to hook up lines to this and then just put it on. So I have to think about what I want to do here. All right, so my out of here, I want to have a T. Actually, I can put my T here and have two lines. One to here, and then one continuing on. Okay, good. So I'm able to make sure that I don't hook a T directly to here. I want to save this. This is really weak, and this thing is sitting here weak. Don't put T's directly on here, and if you do, make sure the hoses are already connected to them. Okay, good. So that guy's going to go in there, and then going back to my diagram, what do? Oh, I go to the extension of the cylinder. Now, in this case, I want to make sure that I use the right cylinder. This cylinder is in the diagram facing up. When you're drawing your Automation Studio, when you're drawing any kind of schematic and you have cylinders that either are going up or going down, draw them either horizontally or vertically. And in some case, maybe on an angle, but draw them the way they are in application. Okay, good. So I'm going to come out of here, and I'm going to go to my cylinder that's going to be extending. Okay, good. So I'm going over to my cylinder, and it's extending. Okay, now back to my diagram. Where am I at? I've done this, I've done this, I've done this, I've done this. Always check your diagram before you move forward. I've done my A line. I'm going to go straight to my B line, and my B line is, oh, it's really simple. It's just a hose. Okay, good. So I'm going to go over here. I'm going to grab a hose. I'm going to go into my B line, and we're done. Now, I'm going to go into here. That's my return line during extension, and my line that makes it retract. Okay, good. So now, if I got my drain, I just have to stop and make sure I got my drain, because if I don't have my drain hooked up, it actually causes real problems with this valve. It'll eventually die, because that fluid, those drops that need to leave, will be stuck in here, and it really creates a lot of damage inside the valve. Okay, good. Now I'm going to turn my system on, and I'm going to go through a very specific process to do that. But I really want to watch my pressure here, and I'm finding that that's a little small, so I want to hook up this pressure gauge so I can actually see the pressure in the system. So I'm going to my pressure line here, and I'm going to put this guy directly over to my meter. So now I can watch the pressure. So my gauge is going to read the pressure again. So to do this properly, I'm going to make sure this is completely counterclockwise. That is in this position. I'm going to now make sure that's in that position. I'm going to turn this thing on. Now, as I'm going to turn that just a little bit, I'm going to turn this and I can see my pressure coming up. I'm going to go over here and I'm going to watch it until it reaches 500. Okay, good. So now I'm at 500. I can make my system go. Okay, let's turn it on, and we're going to adjust our pressure reducing valve so that we do get 350. But right now, I've got it all the way counterclockwise. The way you adjust this is you pull it out and then you turn it counterclockwise. So essentially, I'm just going to make this go now. Here we go. So I'm during extension, I'm going up, and when it does extend, it's only at 50 psi. It's nothing. So I'm going to adjust this, and I'm going to pull it out, and I'm going to turn it clockwise until that reaches 350. Okay, good. Here we go, and it's okay that it's making noise. That's just part of the process. Okay, now I'm at 350. So now my system pressure is at 500. The pressure that is making that extend, the pressure in this line right here is only 350 psi. And that's because this guy, my pressure reducing valve, is closing when it gets to 350. So I'm going to go through the process where I'm going to retract it. You can see that there's low pressure during retraction. That's actually looking at the pressure of the fluid coming out of the cylinder. Because remember, it's studying this line. Okay, now as I extend it, you can see that the pressure is going to be low during extension. When it fully gets out, it'll jump to 350, but it won't jump to 500. Good. So now, you guys are experts. I'm going to put this onto a valve one way or the other. I'm going to make this come down. Then I'm going to do this. So when you shut this down, it's got to be either extended or retracted, but we want to retract all of our cylinders. Okay, good. So now, once I've got zero pressure, I can do this. Again, if you don't do that, we get pressure stuck in some of these valves. And it's difficult because then we got to use a wrench to undo it and let the pressure out. So now you guys are experts at pressure reducing valves. You understand why we use them, and it blocks any pressure beyond whatever it's set to, because it actually closes the valve. So no fluid comes out of it anymore. And the way that the valve knows that is it's studying the pressure coming out of the valve. So if we take a look at this, it's studying the pressure coming out of the valve, and it's saying if that pressure is above 350, shut the valve down, close it. So there we go, you're experts now.